We got together a few months ago after my students and I started building test beds to explore IoT systems. And what we decided is we actually needed to talk to professor or professors that worked in process control because we wanted to build real systems. So I introduced myself to the folks in chemical engineering, and we met and we started talking about doing research together.
And then basically we've been talking on and off. Then the opportunity came that there's a dear colleague letter issued by National Science Foundation, and the National Science Foundation started to focus on cyber manufacturing, and as an initial step they want to solicit novel ideas to make the preparation for future development. So we started to talking about more how to really advance our initial discussion into the actual project. So we talked and we decided that with the Internet of Things, with the big data offered by the Internet of Things devices and the actuators, our group at Chemical Engineering could develop new data analytics algorithms to make use of those data and information.
The Internet of Things is essentially ubiquitous computers and networks and sensors everywhere you go, whether you're wearing them, whether they're in the rooms or spaces that you're in, or whether they're helping make behind the scenes things work better so that you don't notice, like lights coming on 2 minutes before you get into a room to warm up, or the temperature changing when you're about to get out of your car in your driveway. The Internet of Things represents this massive increase of sensors, little computers, networking, and then all the data that comes out of them, and that's the big data piece. Big data piece is only as good as the algorithms and methods that you apply to it to get actionable feedback into a system to deliver a better value to the customer, consumer, or individual.
One specific example, I guess, for this project we can give is that one of the test beds we wanted to build is a continuous stirring mixed reactor. So assuming that you're running a reaction in your reactor, you are converting your raw material into your product. Then if you need to control the temperature and the pressure, and you need to control the concentration in your bioreactor so that there won't be any explosion and your product is on target. It has to meet certain specifications so you can sell the product. So how do you make sure things are going as expected? So you're converting whatever the raw material provided by different vendors to the product that you can sell to different market shares. So one thing is that for the information, based on the information collected through IoT devices, our algorithm will make a decision on whether the process is operating as expected. So there are different scenarios. The algorithm will help you to put different information together to make a decision what to do next.
The whole purpose of collecting the data is you operate the systems that you've already got more efficiently to make the products better, cheaper, safer, waste less energy in the system, so be more environmentally correct, have less waste products coming out of them. But at a meta level, what a company can learn is all about longer term improvements or cross-plan improvements or cross-product line improvements. They can have more flexibility, they can have less waste, they can decide how to make capital investments in smarter ways based on what they're learning. So there's a whole bunch of information about complex systems that involve making things that we use. And when you know more and study more and store more and build that up, which is an aspect of big data, then there's the hope that you could continue to improve the systems, continue to improve what you get more effectively, cheaper, with less harm to the environment.